Dr. Alex Sprintson. He joined NSF as a rotating program director in September of 2018 in the Directorate of Computer and Information Science and Engineering. He manages networking, research within the networking technologies and systems, and secure and trustworthy cyberspace programs. He also serves as a program manager for the NSF Inter-Partnership on Machine Learning for Wireless Networking Systems, program Spectrum Innovation Innovatives, and Platform for Advanced Wireless Research. Alex Sprintson is a faculty member in the Department of Electrical Computer Engineering, Texas A&M University, College Station, where he conducts research on wireless network coding, display storage, and software-defined networks. Dr. Sprintson received the WARF Award for Distinguished PhD Students, the Vatebi Postdoctoral Fellowship, the Thermal College of Engineering Outstanding Contribution Award, and NSF Career Award. From 2013 to 2019, he served as the Associate Editor of the IEEE Translation of Wireless Communications. He has been a member of the Technical Program Committee for the IEEE Infocom 2006 to 2023. Please join me in welcome Alex to the podium.
Okay, thank you very much for inviting me. And kind of previous speakers covered so much, so I will try to be a little bit brief, right? But it's definitely hard to beat previous speakers, especially Ericsson and others, right? So with our vision. So I'm kind of now trying to present view from NSF. So we major funding agency in the US, and we always brag about our past projects that we invested, like probably like 15, 20 years ago, and we see the results now. So basically the same thing with NextG technologies, the investments that we make today, we hope that some of them we will show 15 years later and say, oh, we built this, we invested, and we enable this through many different ways that NSF enables research. So some of them, like we did research on CBRS and millimeter wave spectrum, and Ted Rappaport and others, 5G network architecture with Professor Madhu from Santa Barbara, and RISE project. So it's all those projects very influential. So some of those technologies we hope that will be fruitful for NextG. So our budgets are not as large as Finnish budgets, right? But we are a relatively small agency, but we do invest in advanced wireless. I'm saying proportional to the size of the country. So we do core research. We do cross programs between different directorates. So as you know, like our SWIFT program, we do partnerships with industries and other government agencies. So more recently, we worked with Intel, VMware. That's a new model for us, and kind of a year ago, we started this rings that I'm actually very fascinated that somebody mentioned before I did. So it's like it stole my thunder. But actually, it was really proud for me, like, you know, somebody mentioning rings. So it's our project that I will talk today, and we started it with 9 industry partners, including Ericsson, and we have 2 government agencies that helps us with this. So we're actually having a kickoff in 2 weeks, and we're kind of looking forward for continuing this project. We're also kind of not only providing funds, but we also provide enabling our community through test beds. So everybody knows, like Aloisio, I'm not sure if he's still here, right, from PPO, Power Project Office. So it's basically platforms for advanced wireless research. And more recently, we are investing heavily in Spectrum. Again, I'm very happy that it was mentioned before. So we need to solve spectrum issues, and it's very, very nice program, National Radio Dynamic Zone. So if you're interested, I encourage everybody to look. On deadline is very soon, but hopefully some of you are already working on this. We also have National Center for Wireless Spectrum Research, SpectrumX, that was launched probably like 18 months ago, something like this. And we have AI institutes. Okay, so our continued investments are for long term. So we're not looking for 6G. We're looking for what we call like next generation, which is broadly defined, because we don't want to be tied to particular standards that industry comes up with, which includes many kind of commercial consideration. We're just focusing on basic research. And we hope that kind of some of our technologies will be adopted. This is our really our goal. So we're looking also on advanced Wi-Fi, right? So we shouldn't neglect this, right? Those technologies are widely used, and also very, very interesting standards coming up from that community. And spectrum sharing is, as I mentioned before, we need to use it efficiently and wisely, so we don't ask for 6G spectrum, and we squeeze our partners in passive users, like, for example, astronomers, right? So we kind of look, all next generation, if you're talking like to FCC, they're asking another chunk of spectrum, right? And then we're trying to release the spectrum from 3G, right? So we need to really use it very, very efficiently, and and hopefully we'll come to shared spectrum, right? As was mentioned before, it's real estate, and maybe we can coexist with our other users of spectrum, including, for example, weather satellites or passive users like us, including astronomy. So our building blocks kind of was mentioned before. We're definitely counting on AI to help us with a lot of issues, right, that we're having right now, including complexity of the network. However, we want those AI models to coexist with existing engineering model and complement them, but not necessarily entirely replace them. So again, issues of spectrum, increased spectrum efficiency, security and privacy, it's also need to be ingrained, and it's actually one of the foundation of RINGS program to look on NextG from resilience perspective, because we're building those complex system, but we really need to make sure that those systems are stable and resilient to attacks, because they will be attacked. And they also, like, need to be resilient to failures, right? Also, we see the trends that we increasing softwareization, so we can do a lot of stuff on software. We can delegate a lot of stuff to cloud, to edge cloud. We also think like wireless will have a lot of uses. So somebody, for example, suggested to use sensing, spectrum sensing, using satellites. So it's a lot of like new areas that will be really, really interesting. But we already see spectrum kind of using of wireless technologies for spectrum sensing and imaging. And again, like satellite networks will be important components. So this is some of the research topics that in our roadmap. Again, we're looking very, very broadly. I will not have time to go over all of them, but initially, like eventually we want to get into what we call like self-driving networks, that networks can kind of be really adaptive to disturbances and to attacks. And mentioned here, like support holographic calls and metaverse, but our current medium or short term is ultra low latency. Latency is an important problem, especially if you use 6G for control applications, and ingrained security by design. So we see a lot of improvements and still in terms of security, but we want to think more broadly that we're building highly secure system, because it will be essential. And some other issues, for example, building widely tunable front ends that we can use entire spectrum and achieve the spectrum agility, so not design systems that can only operate with very, very narrow spectrum bands. So some of our programs, again, like we have just finished, not finished, we received proposals for our SWIFT solicitation. Again, the goal of spectrum utilization and on-demand spectrum access, resilient coexistence. And it's also like, since we have a lot of interference from satellites that, SpectrumX and others, we really need to think about how not to kill astronomy, right? So from National Science Foundation, so we need to kind of have this mitigation, and they actually very aware of these topics, but it's still like, with all this NextG and 6G, we need to kind of be cognizant there are other users of spectrum, and also like, even though satellites are emitting too much light. Okay, so for AI technologies, again, like it's a lot of use, right? So we kind of look on them as like kind of translation from linear world to more non-linear world, right? Because our engineering model mostly built for linear systems. And now like AI, hopefully we can do kind of reason about more complex non-real systems. But they do need explainability, and they do need guardrails, right? So because we need to make sure that whatever like AI tell us, right, it's actually reasonable, right? So, and it's But it's definitely a lot of application, for example, for detection, classifications, recommendation systems. It works really well, and anomaly identification. Also for AIs, we need data sets to train AI, right? So we kind of challenge our community. We need to build this ImageNet for wireless, right? So ImageNet was really helpful for advancing traditional machine learning techniques. So we really need to kind of build comparable data sets so we can test those AI techniques that we have. So those some of the examples of the data sets, but we have also like this effort, it's called RF Data Factory out of Northeastern University to try to consolidate and curate those data sets, because if somebody publish them like in kind of random places, it's very hard to validate them and make sure that all metadata is available. So I'm just really kind of if you're interested in data sets, I really encourage you to visit their website and look, they're trying to classify them and try to cover like a broad range of use cases. So this is one of our investment. And also they developed a lot of APIs to access those data sets. And if you have an interesting data set, you can also contribute. Platform for advanced wireless, it's also our effort to provide researchers ways to validate their approaches. Unfortunately, I will not have time to talk about this. I think I have only 5 minutes. Another is investment in an AI institute. So they're also thinking about all different AI techniques and kind of covering networking for AI, how to support AI applications, but also how to benefit, how AI techniques can benefit networking. So for our Spectrum investment, so we have this first SpectrumX was launched, right? Again, we have this national dynamic zone that I already talked about. SpectrumX is out of Notre Dame University. Again, they're trying to think kind of how to rethink all those models that, for example, channel models and other like techniques that kind of probably need refresh, right? So they kind of very, very old right now, right? And how to transition to dynamic spectrum use. So it involves many universities and have many, many different areas, including education of spectrum workforce. And kind of thinking about more systematic principled way, how to spectrum and manage spectrum in a kind of using modern tools that are available today. Again, National Dynamic Zone is again an attempt to create some kind of environment where people can experiment on dynamic spectrum sharing over the air without kind of danger of compromising users, right? So we have National Quiet Zone that we want everybody to be quiet. So here we kind of turn it around and say, you can transmit in this zone, but we can tightly control its boundaries to make sure we're not interfering with somebody outside, but it will allow us to test all those techniques. So we have international collaboration, including with Finland, and we're constantly expanding it. We also are looking at, mentioned here about ORAN. We definitely, our community likes open source, so we have OpenWRT, we have USRPs, right? So now we're going to kind of from software-defined radio to more like for Open RAN. So Open RAN is definitely great for researchers. I not have entirely open source, it's open interface, but it's still creating ecosystems that we have like companies and researchers can actually contribute. So this is some of the projects that we funded in this area. Fortunately, I need to skip this, but we believe that this technology is promising, right? For example, people can experiment with radio intelligence controller, which is where a research community can really implement all those ideas on advanced scheduling, slicing, and so forth, and test those AI models. Okay, so let me just quickly move to NextG. So we again view it as not just cellular, not just wireless, and not a single set of standards. So we kind of thinking that compute, for example, and cloud will, no way I can finish in 1 minute, can you just 3 minutes? Yeah, so kind of on this NextG ecosystem. So NextG is important because what we see is transition from traditional cellular networks, the traditional phones, transition to machine communication. So we kind of thinking, supporting billions of hopefully kind of potentially IoT devices talking over this and bringing new stakeholders, intelligent transportation, smart agriculture, and so forth. So this is like entirely new systems that we use this technology as more dominant way of communicating. And for example, people like for logistics, instead of building their own networks, they can rely on a slice on NextG, and we can make it secure, we can private, we can tune it to the needs on particular resources. And supporting definitely applications is very important. So again, we're thinking about NextG, about convergence, many different technology, including cloud technologies coming together, and some, for example, serverless computing and some, all of this coming together with physical layer techniques, spectrum sharing. We think resilience, and which includes security and intelligence, are super important. Low latency and wider broadband reach of those networks. Okay, so so I will just talk a little bit, if you can just give me 2 minutes, about RINGS. So RINGS goal is to create US-based research communities that brings together both academia and industry. So it's again our first programs that we collaborate with so many industry partners. So we're just really excited about this. So we currently awarded more than 40 projects as part of this program, so it's around $40 million. We're looking for, actually, if you're interested in helping us, there is solicitation out for virtual organizations that will glue industry and our performance or our principal investigators. And we're launching this kickoff meeting soon. So it's a list of our partners. And okay, so again, like what is built in RINGS is just thinking about from resiliency as a primary considerations in these programs. So when people submitted to it, they had to kind of pick one research vector from this resiliency part and one from enabling technologies. So we looked like for all kind of resiliency, including security, autonomy, and other forms of resilience, and then look on technologies, which is including spectrum, new radio, and edge computing, and all this physical and virtual worlds, what Charles was mentioning. Okay, so yeah, this is just breakout some of our sample projects. Unfortunately, I just need to wrap up quickly. And we look forward. And again, thank you so much for contributing. And if you have any questions, probably no time for questions.
Thank you.
I will be happy to answer.
Few questions?
Yeah, so we have advanced wireless. So the question was, I'm not sure if online people heard about the question, if the material is available. So we have advanced wireless on NSF. If you Google advanced wireless webpage, we'll try to update it. Some of these more recent slides are maybe not available publicly because we just launched this program, but we'll definitely keep updating it.
I have a question, Alex. I know NSF is pretty good at collaboration with other research organizations around the world. Do you have any specific guidelines in terms of, we heard a talk from Finland today, right? I know NSF Academy of Finland, you have some collaboration, similar things, right? Would you like to say what other collaborative projects you have with other countries?
Collaboration with other countries. Actually, yeah. I will be in Finnish embassy on Friday, but I was just chatting about this with Roku. But unfortunately, yeah, we do have collaboration with Finland. It's relatively small. We're trying to kind of enlarge it. We have collaboration with South Korea. Again, it's super difficult for us to collaborate because we kind of relatively small group, and it's a lot of issues and trying to solve, right? So we're trying to get this lead agency model in which NSF kind of takes responsibility for selecting projects. And best collaboration we probably have, it's actually with Israel, that they kind of just, we submit a joint project, and if we decide to fund them, they automatically fund it as well. But we kind of look essentially collaboration with Europe, because it's unfortunately those two efforts are not as coordinated as we would like, but hopefully this interaction that we have allows us to work more like synergetic towards those goals. Hopefully answering your questions, Ashutosh.
Okay, one final question from online. In AI and ML-based security, do you think that if we it would be better to migrate to node-driven protection in spite of data-driven protection? This will reduce forwarding complexity introduced by conventional security techniques based mainly on siphoning and PKI and etc.
Yeah, it's probably like, I just need probably more time to digest it, so I will be like politician answering different questions. Yeah, so we kind of think security holistically, right? So it's basically like, when we look on NextG security, it's a beast, right? So it's very, very complicated systems that include, and kind of, I'm working part-time on this security projects. I think about attack surfaces. I'm not sure like it's even like you can list them in like reasonable time, all types of attacks that you can do, right? You can attack data, you can attack from physical layer, you can attack like, all this like cloud, right? And you need to make sure that system survives and provide reasonable service that you can make your Bitcoin trade, even if like cloud is not available, right? So it's again, like we're looking on the system as like life-saving because if people like looking to do like, telesurgery, right, that I would not recommend to anybody right now, right? But, if network is under attack, we still want that doctor will have access to those instruments. So we look on those like advanced, we actually have one of the, like heard about PKI and stuff like this. We're looking how to kind of translate some technologies that, was done elsewhere, like for example, privacy into NextG, right? Because it's, like, for example, some of the post-scriptum stuff, post-quantum stuff, right? How those technology can kind of be in, kind of thrive in this NextG area. Okay, but I will be happy to come back to questions. I just need to understand it completely. Okay.
Yeah, thank you so much for your fascinating talk. As a token of appreciation, we have this gift for you. Thank you.
I'm not allowed to accept gifts, so I will just give it.
It's less than $20.
Thanks.
All right. Now, Jeff is going to introduce the next speaker.